So preparation of alkanes, we have multiple methods. So we are going to discuss few methods over here. So one method is through Grignard reagent. So first of all, what is a Grignard reagent? Grignard reagent is a reagent which is prepared by the reaction of alkyl halide with magnesium in the presence of ether. So it is represented as RMgX. This Grignard reagent, example of Grignard reagent. Here, it is formed by the reaction of alkyl halide with magnesium in the presence of ether. We get RMgX. So this is Grignard reagent. When it reacts with any species, then magnesium gets a positive charge and alkyl groups gets a negative charge, R minus. Now, when we have any proton donor, any species which can give us H plus, then you have R minus over here in Grignard reagent, and we get H plus from species such as water, alcohols, carboxylic acid, and we get alkane. Check it out here. We have, if we take let's say CH3 MgBr and we let it react with water, alcohol, carboxylic acid. For that matter, if you take a terminal alkyne, RC triple bond CH, alright, or you take a phenol. So all these have acidic H. All these have H plus. If you agree with me, H plus is present on all of them. Water gives H plus OH minus, alcohol gives RO minus H plus, carboxylic gives RCO minus H plus, and this gives terminal alkynes. The carbon attached to triple bonded carbon is sp carbon, and hydrogen is the acidic hydrogen attached to the terminal alkynes. So all these have H plus. See, this is H plus, this is H plus, H plus, H plus, H plus. And in Grignard reagents, for example CS3 MgBr, the carbon attached to magnesium breaks the bond like this, CH3 minus. The carbon which is attached to magnesium gets a negative charge. Now CH3 minus combines with H plus, combines with H plus, combines with H plus, combines with H plus, combines with H plus. And what do you get? CH3 minus with H plus forms methane in all cases. I hope you agree with me that in all these cases we will get methane. If it was C2H5 MgBr, then we can get ethane. If it was C3H7 MgBr, we can get propane. So any Grignard reagent when reacts with H plus donating species, alcohol, carboxylic acid, water, ammonia, amines, phenol, terminal alkynes, which can give H plus, then R minus from RMgX Grignard reagent and H plus from these species form RH, which is alkane. So this is one method which is used for the synthesis of alkanes using Grignard reagent. I hope you understood this. Now there is another reaction, Wood's reaction. Wood's reaction. What happens? We take 2 moles of alkyl halide Rx plus 2 moles of sodium, then we take another Rx, and the simple mechanism happens over here. 2 moles of NaX are removed and both of these R combines with each other and we get the product R and R. It is a free radical mechanism where you get 2 R's combining with each other and form RR, which is alkene. So this method is very good for the formation of symmetrical alkanes. Symmetrical alkanes are formed using this method. That the alkanes have even number of carbons. The alkane form has even number of carbons because we take alkyl halide, both the alkyl halides are taken same. If you are taking methyl bromide, then take another moles of methyl bromide, then the reaction productivity will be high. So methyl bromide gives methyl is left out and they combine and form ethane. If you take ethyl bromide, then 2 moles of ethyl bromide will be taken. So Br will be removed, C2H5 combine with each other, you get butane. And for the formation of hexane, I think you will agree with me, then we take 2 moles of propyl bromide. So 2 propyl groups are left after removal of Br. So 2 propyl will combine with each other, we will get hexane. Now answer me, if I have to prepare decane, so what will be the alkyl halide you will take? I think you will say we will take alkyl halide which will have 5 carbon atoms. That means pentyl bromide will be taken 2 moles, then we will get 2 5 carbon chains you will get, and you will combine them and we will get decane. Alright. So that is what is happening over here. Alright, 1 degree, 2 degree gives alkane and 3 degree gives alkene in this reaction. And don't forget the solvent over here, that is also important. Dry ether is the requirement. So sodium, alkyl halide and dry ether are required for Wood's reaction. This is a very important method for symmetrical alkane formation. Even number of carbon containing alkanes are formed through this method. Unsymmetrical alkanes are not produced in a good way through this method. So always remember, Wood's reaction means symmetrical alkanes, even number of carbon containing alkanes. That's it. Thank you.